All right, got it. Now, in the last session, we have run the logistic regression on seasonal vaccine, if you remember, right? We have run the logistic regression on seasonal vaccine. Now, library carrot. Library carrot. Confusion matrix as dot factor wax strain DF dollar seasonal vaccine. Hey, we had a problem here. Yesterday in wax strain DF, we are getting X. We have used wax strain DF, right? There's something called X. Serial numbers are there. -1. No, me clear. I think for me it is still there. X is there, na? X ane undi. So there was 77.67 I got accuracy. I think wax test also we had X. Okay, so we had wax strain here dollar seasonal vaccine, comma, as dot factor, logic predict, yeah, typing the command again. Confusion matrix as dot factor wax strain DF dollar seasonal vaccine, comma, as dot factor logic predict, comma, mode is equal to prec underscore recall, comma, positive is equal to 1. Seasonal vaccine 0 and 1 only, right? Logic predict also 0 and 1 only, right? No. No. I think I have not converted logic predict. Logic predict is equal to if else logic predict greater than equal to 0.50, comma 1, comma 0. Logic predict, we did not convert it into classes. That's the problem. Now we got it. convert logic predict into 0 and 1. You have to convert logic predict into 0 and 1. If else. Right? Once you converted it into logic predict into 0 and 1, now you can see here the problem. The problem is not problem. This is the balanced data. Seasonal vaccine is a balanced data. Accuracy is 77.68 and precision, recall, F1 score are all closer to 77. Precision, recall, F1 score all are written closer to 77. Now, build a logistic regression model on H1N1 vaccine. Build a logistic regression model on H1N1 vaccine. So H1N1 underscore logic is equal to GLN open bracket H1N1 underscore vaccine tilde dot comma data is equal to H1N1 X underscore train. There is X minus 1 comma family is equal to binomial. Summary H1N1 underscore logic. So we have built the thing. I think similar thing is happening. H1N1 underscore logic underscore predict is equal to predict H1N1 underscore logic comma type is equal to response. Which one? Huh? Which other? What? So that means you have not converted it into 1 and 0. Did you run this line in the logic predict? In the logic in the previous yesterday session, after predicting on logic, I told you to use if-else statement to convert it into 1 and 0. Because prediction in logic will come in probability. It will not come in 1 and 0. Whereas your classes are in 1 and 0. So first convert the probability into 1 and 0. Logic predict. This line you have to add to your previous code. Check the name what you have given to your data frame. Once again, let me complete this and I'll sort it out. So again, H1N1 underscore logic predict is equal to if else H1N1 logic predict greater than equal to 0.50 comma 1 comma 0. confusion matrix as dot factor H1N1 underscore vax underscore train dollar H1N1 underscore vaccine, comma, as dot factor H1N1 underscore logic predict, comma, mode is equal to prec underscore recall, mode is equal to precision underscore recall, comma, positive is equal to 1. Now, if I look at the overall accuracy, I got accuracy of 83.19, but look at the prevalence, recall and F1 score, 40, 67 and 50. Accuracy is 83. Overall accuracy is 83, but the precision, recall and F1 score are very bad. So for imbalanced data, along with accuracy, precision, recall is also called as sensitivity, precision, recall, sensitivity, and F1 score must be closer to accuracy, must be checked, and all three must be closer to accuracy. In this case, they are not. So that is what we have to check in imbalanced data. For imbalanced data, the problem comes, your precision, F1 score and other metrics will not be closer to accuracy. H1N1 vaccine is an imbalanced data, and which is also showing that the accuracy is good. Accuracy is 83.19%. But when you look at the F1 score, precision and recall, they are very, very bad. Precision of 40%, recall of 67.1, F1 score of 50%, but the accuracy is good, 0.8319. So in imbalanced data, these three metrics also have to be looked upon. Now, we have to balance the dependent variable for improving the prediction. So we have to balance the dependent variable. We have to balance the dependent variable. Now, when I say balancing, we can do undersampling. What is undersampling? Yes. Randomly delete rows or observations from majority class and equate it with minority class. That is one method. Undersampling is one method where you randomly delete rows or observations from majority class and equate with minority class. Similarly, we have another technique called oversampling. What is oversampling? Yes, randomly duplicate rows or observations from minority class and equate it with majority class. Equate with majority class. So for balancing, there are two strategies: undersampling strategy and oversampling strategy. Okay, so install.packages, rows, ROIC, all caps, rows, install.packages, ROIC, rows, library, rows, library, rows. All right, all of you have installed. So under sample is equal to, first we will use the undersampling. O1.sample H1N1 underscore vaccine tilde dot comma data is equal to H1N1 vax underscore train square bracket -1 comma method is equal to under dollar data. Table undersample $H1N1 vaccine. So see, we have majority class is brought down from 21,000 to 5,650. Under logic is equal to GLN open bracket H1N1 underscore vaccine tilde dot comma data is equal to under sample, data is equal to under sample, comma family is equal to binomial. Family is equal to binomial. Summary under logic. Summary under logic. I think we got a similar output like the old ones. Same variables are significant. Under logic, predict is equal to predict under logic, comma, type is equal to response. Predict dot glm. Type in help predict dot glm. You got type is equal to link, type is equal to response, type is equal to terms. You can see what it means in the help. Under logic predict is equal to if else under logic predict greater than equal to 0.50, comma 1, comma 0. Confusion matrix as dot factor undersample $H1N1 vaccine, comma, as dot factor under logic predict, comma, mode is equal to rect underscore recall, comma, positive is equal to 1. So when you do under logic model building, you got overall accuracy of 75.81 and all the three metrics, precision, recall and F1 score are closer to 100. So undersample has worked in this case where we have the overall score of 75%, which is above 0.70, and all the metrics are also above 0.70. Huh? Even overlapping? That go to logic predict and convert it to 0 and 1. We have to convert it from, you have to convert it into 1 and 0. See, type is equal to response will give you only predictions, so probabilities between 0 and 1. You have to use if else statement to convert the probabilities to 1 and 0. If else, the predict is greater than equal to 0.40, comma 1, comma 0. You have to convert the probabilities into class predictions. Got it? What happened? You have to do hard. There is nothing. I will happily. So use Kaggle. Na? If you are having problem with R in your system, use Kaggle. Kaggle also has R, right? But it's a Jupyter notebook, not RStudio. Or use RStudio Cloud. Use RStudio Cloud. Why you are worried about this? Use RStudio Cloud. Yeah. You have to look at the trained test data. What changes are happening? You have to do an exploratory data analysis on test data and see whether it is closer to your trained data or not. The thing is, when there is too much of variance or noise in your test data, which is not there in your trained data, then you have to find models that adapt to that. Test data, how you got 50%? You submitted on the competition, huh? Then how will you know? No, how can you say it's not there on test data? You have to submit it now on the competition side. You have to submit it to the competition side, then only you will know. Otherwise, nothing. But in real-time situation, you will face this problem of test data not having lesser accuracy. Then immediately you do an exploratory data analysis of test data, compare the test data variables and the trained data variables. Sometimes you might see more skewness in test data, sometimes all that thing. So you have to find models that adapt to these changes, which are your neural network models. Neural network models are widely used when you have test data which constantly has variations which are bigger than your trained data. Or resample your trained data in such a way that the test data variance is also taken into consideration. That's a constant thing you have to do. The test data constantly changes, but particularly when you're working on bank data, credit default, loan default. You will see loan defaults in January, February, March. Because government employees, they have deductions of income tax. Income tax is deducted. So their salaries will be less. They will either what you call skip on the personal loan payments or home loan payments. They will get their full salary back in the month of April. So you will have defaults rising in the month of February, March. So you have to be, the data will not match with the other months. So you have to do the changes. You have to take previous years, that quarter's data, and then build a model and use it for predictions. You can't use the month's data of, let us say, July, August, September, or you can't do September, October, November, when they get bonuses and all. That data cannot be used to predict the default event. So, like that, you have to make changes in the trained data. That's all you have to do based on your understanding of the data. Why is my test data behaving badly? You have to do an exploratory data analysis on test data, compare its performance with your already done EDA on trained data, and identify what is the variance. Accordingly, you have to resample your data, or you have to find models that work with those variant data, which is a neural network or a random forest or a boosting trees. Probabilities, cross tabulation, class probabilities will be different. So that also will be there. So see, it's all about understanding the data. See, data is completely different. You can't build a model and I'll sit for next 2 years. No, it doesn't happen like that, like what happens in Java. You build a program, you forget it for 2 years, nobody asks until an update of Java comes and this will stop running. Then you update the Java JDK and then you do all those things, it will work. But it's not like that here. Your model will fail next month only because there is a change in data. You have to go back and rebuild your model completely from scratch. Yes, you have to do it. That's what you are paid for. That's what you have to do. Netflix, you heard Netflix. They have lost subscribers. Big drop in subscribers. Now they have to rework their whole India model. Otherwise, their business is out. You can't simply say, no, we can't say like, no. All of this have to be changed. Models have to be changed. Content has to be changed. You have to rework it. They are working aggressively on Indian data. Why people are watching Prime? Why they are not watching Netflix? Other OTTs are watching. People are watching Telugu. There is AHA, which is a big hit. Tamil Sun is a big hit in this one. Z5 is a big hit. And then you have Heroes, Shamaro, those traditional cassette companies. They all become OTT companies. T-Series, Heroes International, Shamaro, your Hyderabad-based, what is that one? Audio company. Saregama, something is there, no? That is also is now OTT. Lot of OTT is there. Entertainment, they are looking for people for analyzing the data, OTT data. Now they are blindly doing content because they have money. At some point, the money will be over, right? They have to do the content which is liked by people. Now, what is the happening is Amazon has given $400 million for Indian content. They will build all nonsense content. They will build. Whether it will hit or not, they will not bother. But after the 400 million, what happens? The company will ask, okay, now you have used this money, show me the results. What you have done, which content is working, which content is not working. Accordingly, they will allocate content money to that content which works. If they will not allocate money to that content which doesn't work. So all these things are analyzed daily, day to day, live analysis, streaming analysis. That's where you have to do. That capability we should have. We should respond in hours. The response times are very fast. So that you have to be very, very careful. So don't think that data models are there forever. No. They are very short span models. That means very short lifetime. You have to constantly update. Who knows? If you are working on weekly data, it is the same problem. If you are working on weekly data, retail sales, same thing. If you look at Amazon, it uses weekly data. Flipkart, weekly data. Swiggy, weekly data. Ola, weekly data. Everything is weekly data. Huh? That's what. Intellectually, you should be capable. See, I am telling you guys, you have to think. You are not thinking, you have to think. Find ways. Company will not help you. Right? Nobody in company will help you. You should find methodology. Like one guy called me saying, sir, they are not helping me. What should I do? I told him you have to use this strategy. That's all. You have to come back to me. I can only help you in terms of words. I can't do it for you, right? I can't even see the data if it is confidential data. That guy was working on confidential data. He can't show me the data. He can only tell me about the data. Then I was telling, based on my understanding of what he's saying, I suggested something. That's all I can do. But actually, you are responsible, right? That's all. That mode you will get adjusted. Don't worry. Don't think that you will not be able to do. Once you fall in that track now, your mind will adjust to the short spans. Take, for example, I am teaching you R. I am teaching one batch SQL. I am going to teach one batch Python. I have to adapt. What can I do? I can't say I will teach only R to all, right? Understand my problem. I am teaching you R. Finally, I am teaching other guys SQL outside in other college. And I am teaching predictive analytics using Python. So, 3 softwares for me in 1 week. You also have to adapt. There is no chance, no option for you. You can't say I will not adapt. You have to adapt. Done? Undersampling is done. Now, exactly like this, do oversample. Only change is method is equal to over. Rest of is all same. Wherever under is there, make it over. Do oversampling. Exactly the same code where method is equal to over. The only difference is method is equal to over. So always if having problems with R, migrate to RStudio, RStudio Cloud. There is an RStudio Cloud version. Or Kaggle, which is Jupyter Notebook, same commands, slide change and import in the data. That's all. Or IBM Cognitive class, also has RStudio, IBM CC Labs. First do your OS updates, then everything should fall in place. See, I've seen people struggling with Python. One of my students called, what is Python version now? Anaconda 3.9, right? We have on 3.0. Now everything is giving error. That guy is not upgrading from Python 3.0 to 3.9. That's the sort of errors also will happen. Version errors, we call them. Update version, everything will fall in place. Anaconda Navigator RStudio, it is again Jupyter Notebook. You can try that also. You can install R in Anaconda Notebook, but I would not suggest it because you have to create an environment and do it. You have to create, and rather than that, I would suggest RStudio Cloud is best. For you guys, RStudio Cloud will be best. You can use your Gmail ID to log in. So RStudio Cloud is easy, same interface, but only thing is you have to upload the data first into cloud and then run the read.csv file.choose commands. So you have to create a project. First upload the data here. On the right bottom, you will see update what you call upload of data. Upload the data and then run the read.csv file.choose commands. This is a cloud version of RStudio. Only thing is maintain that you have a little bit high speed internet, that's all. Okay, so this comes with RAM of 8 GB RAM. It comes with 8 GB RAM, 4-core CPU. Okay, for our 8 GB RAM is okay, and you have to just upload the data here first, and then run the read.csv and file.choose. That's what. If you correct the sampling, it will come. But did it increase? Oversample. Same 75 important. Over.sample H1N1 underscore vaccine tilde dot comma data is equal to H1N1 underscore vax underscore train square bracket -1 comma method is equal to over $data. Table oversample $H1N1 vaccine 21,000. Over logic is equal to GLN H1N1 underscore vaccine tilde dot comma data is equal to oversample comma family is equal to binomial. That means no change. Summary over logic. Consider setting similar variable star marks I can see. Over logic predict is equal to predict over logic comma type is equal to response. Over logic predict is equal to if else over logic predict greater than equal to 0.50 comma 1 comma 0. Confusion matrix as dot factor over sample $H1N1 vaccine comma as dot factor over logic predict comma mode is equal to prec underscore recall comma positive is equal to 1. So overall accuracy is 76, slight improvement. All of them are closer to 1 another. So oversampling is done. So we have done undersampling, we have also done oversampling. Now it's 11 o'clock. Let's take a break and then come back and do our statistical methods, which is SMOTE and random oversampling. So synthetic minority oversampling techniques, it creates synthetic data in minority class to equate it with majority class. SMOTE uses distance method and calculates the distance to the closest neighbors based on given k value. Based on given k value, it will calculate the distance between. Also uses a random weight generator as weight and works only on numeric data. So this is the SMOTE algorithm, which is the popular algorithm in data science. So SMOTE Okay, I think we have to import SMOTE family. Rows, there is no SMOTE. SMOTE in R. So DMWR. So install.packages enwr. Library BMW R2. Okay. It is BMW R2. BMW R2. Okay, no problem. SMOTE data is equal to SMOTE why SMOTE is not appearing. I think SMOTE family also has to be installed. SMOTE. Why it is saying internal server error? SMOTE. H1N1 underscore vaccine tilde dot comma data is equal to H1N1 vac strain square bracket -1 comma నా దాంట్లో ఎక్స్ వచ్చింది. Why it is saying internal server error SMOTE? Data is equal to H1N1 vaccine. Sorry. Okay, dollar data is not there, sir. Correct? You got the output? SMOTE documentation వచ్చిందా? I'm getting it. Yeah, but I am getting internal server error. Why I am coming there? Wait. So H1N1 vaccine, how many are there? 37 are there, right? Data non-numeric. Why it says data non-numeric? Cannot work on because it is all character data, factorial data. So we can't run the SMOTE on this data. Here we can run rows. So rows is also a synthetic data generator. Rows generates synthetic data both from majority class and minority class. So there is an algorithm called rows in R, which generates data from both majority class and minority class. It works with categorical data also. It works with categorical data, which is our case. Our case is all categorical data, right? So we can use the categorical data. Rows sample is equal to rows H1N1 underscore vaccine tilde dot comma data is equal to H1N1 underscore vax underscore train dollar data. The current implementation of rows handles only continuous and categorical variables. Yeah, we have only categorical variables. Which one? Which one? This one, huh? H1N1 underscore vax strain is equal to L apply H1N1 vax strain comma factor. H1N1 vax strain is equal to data dot frame H1N1 underscore vax underscore train. Now rows and now it train. Oh, yes, you're right. So table row sample dollar H1N1 vaccine. So 13,200, 13,500, majority and minority class. So now rows logic is equal to GLN H1N1 underscore vaccine tilde dot comma data is equal to H1N1 vax strain air bracket -1 comma. Oh, I forgot square bracket -1 here. comma, family is equal to binomial. Summary, rows project. Rows logic predict is equal to predict rows logic comma type is equal to response. Rows logic predict is equal to if else rows logic predict greater than equal to 0.50 comma 1 comma 0. Confusion matrix as dot factor row sample $H1N1 vaccine comma as dot factor rows logic predict comma mode is equal to threat underscore recall comma positive is equal to 1. Oh, we got a very bad accuracy here. Oh, it completely failed. Oh, Rose has completely failed. Permis mode is not working. Rose is not the correct methodology for logistic regression here. Rose, you can try it on vaccine train, the decision tree model, all those things might work. You also got the very bad result, right? Data I claim is on the right side. Hello. లేదు 20th తర్వాత పంపించింది 20th తర్వాత మ్యారేజ్ ఫంక్షన్ జరిగింది రేపు 20th వస్తుంది. Got it? Corrected it? It is. So in that setting, Python is better. But let's try decision tree on this. If decision tree gives us a good score on rows data, try decision tree on rows data.